Dear students, today we shall take up few more examples for finding out area under a curve. Let's take first example. Find the area of the loop of the curve x into x square plus y square is equal to a into x square minus y square. Now this equation can also be written as y square into a plus x is equal to x square into a minus x. So if you trace this curve, the curve is symmetrical about x-axis. If we put y is equal to 0, we get x is equal to 0 and x is equal to a. So curve passes to the point 0, 0 and a 0, and asymptote of the curve is x is equal to minus a, which is obtained by equating coefficient of y square equal to 0, that is a plus x is equal to 0. Now we have to find out area of this loop. So we shall find out area of the upper portion and then multiply it by 2. Limits for x are from 0 to a. So therefore required area is 2 times 0 to a y dx. Now substitute the value of y from here, which is x into root of a minus x upon under root of a plus x, and then dx. Now multiply the numerator and denominator by under root of a minus x. So in the numerator we have area is equal to 2 times 0 to a x into a minus x divided by under root of a square minus x square dx. Now because we have obtained here under root of a square minus x square, so for integrating we substitute x is equal to a sine theta. So when x is equal to a sine theta, dx is equal to a cos theta d theta, and substitute these values here. So limits becomes from 0 to pi by 2. So area is equal to 2 times 0 to pi by 2 a sine theta into a minus a sine theta upon under root of a square minus a square sine square theta, and dx is a cos theta d theta. Now a square minus a square sine square theta is a square cos square theta. Square root is a cos theta. So a cos theta gets cancelled. So we have this is equal to 2a square 0 to pi by 2 sine theta into 1 minus sine theta d theta, which is 2a square 0 to pi by 2 sine theta d theta, I missed d theta here, minus 2a square 0 to pi by 2 sine square theta d theta. The integral of sine theta is minus cos theta, and for integrating sine square theta either use gamma function or use sine square theta is equal to 1 minus cos 2 theta upon 2, and substitute the limits, you get it as a square upon 2 into 4 minus 5. Second example. Find the area bounded by the curve xy square is equal to 4a square into 2a minus x and its asymptote. Now because powers of y are even, so curve is symmetric about x-axis. Now what are the asymptotes? If you equate coefficient of use equation coefficient of y square, which is x, so highest power of y is 2 and its coefficient x, so the asymptote is x is equal to 0, that means y-axis. And if you trace this curve, shape of the curve will be like this. So we have to find out area between the curve and its asymptote. So again we will find out area of the upper portion and then multiply it by 2. So therefore required area is 2 times 0 to 2a y dx. Substitute the value of y from here, which is 2a under root of 2a minus x upon under root of x dx. Now to integrate it, we substitute x is equal to 2a sine square theta, which implies that dx is equal to 4a sine theta cos theta d theta. Now in place of x put 2a sine square theta, and in place of dx put 4a sine theta cos theta d theta, and when you simplify it, you will get it as 16a square 0 to pi by 2 cos square theta d theta. So integrate cos square theta and put limits, we'll get the answer as 4 pi a square. Let's take next example. Find the whole area between the curve x square y square is equal to a square into y square minus x square and its asymptotes. Now if you find out asymptotes of this curve, you will find asymptotes parallel to y-axis as x is equal to plus a and x is equal to minus a. And curve is symmetric about both the axes. And if you trace, origin satisfies this equation. Tangents at the origin are y is equal to plus x and y is equal to minus x. So if you trace this curve, shape of the curve is like this. We have to find out area between the curve and its asymptote. So we have to find out this area and then multiply it by 4. So limits for x are from 0 to a. So required area is 4 times area lying in the first quadrant, which means 4 times 0 to a y dx, which is 4 times. Put the value of y from here. You will get 4 times 0 to a under root of a square x square upon a square minus x square dx, which is 4 times 0 to a ax upon under root a square minus x square dx. Now put x is equal to a sine theta. So when x is equal to a sine theta, dx is a cos theta d theta. So therefore area is 4a times 0 to pi by 2. In place of x, we have a sine theta upon under root of a square minus a square sine square theta into a cos theta d theta. Again a cos theta will get cancelled. So we have 4a square 0 to pi by 2 sine theta d theta. Integration of sine theta is minus cos theta. Put the limits and the answer will come out to be 4a square. Alright. Okay. Now let us see how we can find out area between two curves. Suppose we have a curve y is equal to fx, and suppose the second curve is y is equal to gx, and suppose these are the two lines parallel to y-axis, x is equal to a and x is equal to b, and we have to find out area between y is equal to fx, y is equal to gx, x is equal to a and x is equal to b. That means we have to find out area of the shaded portion. So the area will be this area minus this area. That means required area is a to b fx minus gx dx. This you have studied in 12th class also. Okay. Let's find out the area included between the curves y square is equal to 4ax and x square is equal to 4ay. So y square 4ax, this parabola, vertex is 0 0, axis is x-axis, and x square is equal to 4ay is this parabola, vertex is 0 0, and axis is y-axis. Okay, so let's find out points of intersection of these two parabolas. So square this. So we have y to the power 4 is equal to 16a square x square. Put the value of x square from here. So we have y to the power 4 is equal to 16a square multiplied by 4ay. So therefore we have y to the power 4 minus 64a cube y is equal to 0. Take y common. So y into y cube minus 64a cube is equal to 0. That means y is equal to 0. And from here we will get y is equal to 4a. Substitute these values of y here and we'll get corresponding values of x as 0 and 4a respectively. So therefore points of intersection of these two parabolas are 0 0 and 4a 4a. Now because we have to find out this area, so we'll find out this complete area and then subtract this portion. So therefore required area is 0 to 4a. Now what is y for this parabola? Y from this parabola is under root of 4ax dx minus 0 to 4a. Now for this parabola, what is y? Y is x square upon 4a to dx. Now integrate take root 4a outside the integral. So there we have 2 root a. Integration of root x is 2 upon 3 x to the power 3 upon 2, limits from 0 to 4a, minus 1 upon 4a. Integration of x squared is x cube upon 3, limits from 0 to 4a. So put the limits and we will get the area between these two parabolas as 16 upon 3 into a square. Let's take one more example today. Find the area of the segment cut off from the parabola y square is equal to 2x and by the straight line y is equal to 4x minus 1. Now y square is equal to 2x is a parabola of the form y square is equal to 4ax. So shape of the curve is like this, and we have to trace this line also. Y is equal to 4x minus 1. So if we take x is equal to 0, we get y is equal to minus 1, and if we take y is equal to 0, we get x is equal to 1 upon 4. So the straight line passes through 0 comma minus 1 and 1 upon 4 comma 0. So we have to find out area between this parabola and this straight line, is this area. Now in this case, we will make use of the second formula, that is area c to the x dy. Now you solve this parabola and this straight line. So solving y is equal to 2x and y is equal to 4x minus 1. From here, x will come out to be y plus 1 upon 4. So put it here. Y square is equal to 2 times y plus 1 upon 4. So cross multiply 2y square minus y minus 1 is 0. Factorize it. Y minus 1, 2y plus 1 is equal to 0. So therefore y is equal to 1 and y is equal to minus half. So parabola and straight line intersect at those points where y is equal to minus half and y is equal to plus 1. So we will find out this area, and then from this area we will subtract this area between y-axis and the parabola. So required area is minus half to 1 x dy, where x is of the straight line, right? So we'll get this complete area minus half to 1 x for parabola dy, means we subtract this area. Now what is x for the straight line? X for the straight line is y plus 1 upon 4, and x for the parabola is y square upon 2. So integrate it, 1 upon 4 outside the integral sign. Integration of y is y square upon 2 plus y, limits from minus half to 1, and integral of y square is y cube upon 3. So we have 1 upon 6 y cube minus half to 1. So put the limits. So we'll get the answer as 9 upon 32. Okay, so we have taken these two examples for finding out area between two curves. We shall take few more examples of these types in the next lecture. Thank you so much.